Learning Objective D, we're going to evaluate some natural log models. What if they wanted us to evaluate the natural log of e to the 3.14 power? So one of the things we might do is this. Let's first rewrite this so I can actually see the base. This just means log base e of e to the 3.14, and the question is, what does it equal? Well, if I have a logarithm that I can't solve, easiest way to do it is to write it as an exponent. So this is log base e, so it's exponent base e to the x power equals this. So what I have is e to the x equals e to the 3.14. So these two have to be identical, therefore x must equal 3.14, which means this right here is the number 3.14. Let's take a look at this one here. Now here we have an exponent, and we're not really sure how to evaluate e to the natural log of 2. So why don't I set this equal to x, or we'll even just do question mark in this case, and let's rewrite it as a logarithm. So it's exponent base e, so therefore it's going to be log base e. So log base e of this equals this. So log base e of question mark equals the natural log of 2. Well, wait a second, I know the log base e is natural log, so I can just rewrite this as the natural log of something equals the natural log of 2. Well, these have to be identical, therefore I know my question mark equals 2. That means this value here is the number 2. So when you see something that looks very complicated, and if it's a logarithm, remember, just rewrite it as an exponent. Conversely, if you have an exponent that looks complicated, rewrite it as a logarithm, and hopefully the answer will just pop out in front of you. Now the last thing I want to show you is how this might be used. It says here, under certain conditions, the height, h, in feet above sea level can be approximated from atmospheric pressure, which is P, in pounds per square inch. So PSI is what our tires use in our car. Here's an equation that they have that deals with, again, the h here is the height above our sea level, P is the atmospheric pressure. And what this tells us is that human blood boils at 0.9 psi. In this situation would be fatal. It's not a good thing. At what height above sea level will your blood boil in an unpressurized airplane cabin? Well, we know that blood boils at a 0.9 psi. So all we have to do for this is take 0.9 and put it in for P. So at what height is the question? Natural log is 0.9. So all we really have to do is a little substitution and then just order of operations on this. What you're going to do first is calculate the top half, take that answer and divide it by this number on the bottom, and what you're going to get is that the height is going to become 71,621, and we are talking feet on here above sea level. So if you're in an airplane that's above sea level by over 71,000 feet and the pressurized cabin goes out, you're not going to be sitting pretty.